All right. Hello, everybody, and thanks for coming. My name is Daniel Kolesa, and I'm a programmer from the Czech Republic. I'm currently employed by the Samsung open source group, but I'm not attending on their behalf for this time. So I've been involved in open source software since 2007, and I have a background in graphics toolkits, mainly the Enlightenment Foundation libraries, of which I've been a long-time developer by now, and I have also some background in programming languages and game development, maintaining my own engine and other things. I have no PowerPC background before actually starting to get into Power 9. So here's some photos from when I was starting off. In October 2018, I ordered a Talos 2 board with Power 9 from Raptor. It's mainly because I liked the openness of it. I didn't care much for the architecture itself. So they shipped it in November, and then in December it finally arrived. And it worked, but I didn't have any of my favorite systems on it, so what would I do? By now I have multiple PowerPC systems on 6 flavors, and by now it's more like 50K. First I used Ubuntu, which was not really my cup of tea kind of thing. I really like FreeBSD, and I used FreeBSD on many of my systems over the years, but it's not ready for me for many reasons. Right now they have no little endian support, which is kind of important for anybody caring about modern graphics, because the drivers are not in a great state on Big Endian. The software stack is lacking. I don't think they have, for example, even a single web browser with JavaScript support by now, which, like, in an ideal world, I would be okay, but this is not the ideal world, and I need a browser with JavaScript. And I needed a production environment as soon as possible, but I didn't have any of prior experience with Power. On the other hand, I had lots of experience with hacking things together. So Void Linux. It's an independent distro since 2008. It's based on it was originally created for a custom package manager called XBPS as a test bed of a kind of thing. It's very BSD-like and focused on simplicity and pragmatic approach. It's rolling release, stable software, binary-based. Which means it actually updates continuously, but it doesn't use bleeding edge software. It uses stable versions usually. There are some differences from usual distros, which you will find. It uses libsSL as the main SSL library instead of OpenSSL. You get 2 choices of C library implementation, either glibc or muscle. It allows for easy source builds from scratch, as well as easy cross-compilation. The entire system, minus some 10% of packages, can be cross-compiled to any target the system supports, as long as the software actually supports the specific architecture. Officially, it's available on x86, including x86-64, of course, ARM, either 32 bits or 64 bits, and MIPS. It has a friendly community and is open to change design ideas, which was a good target for having Power support. So let's get started. Void has a tool called XBPS SRC. It's a collection of recipes which you can use to build binary packages from source. They are called templates in Void. It's sort of similar to FreeBSD ports or Gen 2 portage or similar systems which let you build from source. It uses minimal unprivileged containers based on user namespaces by default, but there's a few choices, including bubble wrap, proot, or different namespace-based solutions to build the stuff. It's for security as well as no dependency leakage, so you have a consistent, simple environment into which only build dependencies are installed. That ensures you never forget to specify any build dependencies. There's an extensive cross-compilation support, and writing support for new architecture is basically defining a build profile and then building it. So, step 1 is defining build profiles for our targets. A profile defines targets triple. For a little endian PowerPC 64, it's PowerPC 64 unknown Linux GNU with glibc. some default compiler flags and linker flags, and possibly some other basic things like Rust triple and other things. The step 2 is updating helpers for build systems, which we have, so you don't have to actually write the templates from scratch, like invoke the build systems and so on from it. Instead, you just specify, for example, build style Meson or build style CMake or something like that. We needed to update this to recognize the new targets, and this was done. Step 3 is updating packaging recipes for core system packages, so you can actually get a core system built and recognize the new targets and bootstrap. The simplest way to bootstrap a new distro from to Power is using cross-compilation from, say, an x86 box. This was not chosen for little NVPC 64 because I already had Ubuntu running and I didn't have a suitable x86 machine I could do it from. So if you do this, you use another void installation on another architecture to cross-compile the initial package set. Then you use that to bring up the minimal container I mentioned, and then continue from there. Yeah. So to enable cross-compilation, we need to create a cross-toolchain template. This is basically a standard package which contains a cross-compiler for the given target. It's a template like any other. There are some slight differences for it, but nothing significant. It also contains, besides the compiler, a C library and some core libraries which are not provided by the repos themselves. It's in a separate system root, say user PowerPC 64 Linux GNU. XBP SSR uses this to install dependencies into and host dependencies, the stuff you need to run, into the root and build similarly to native. The drawback is that you cannot run tests because the compiled binaries will not work on your host architecture. So, and also not everything is cross-compilable. For native bootstrap, it's a bit more difficult. There's a bootstrap command in XBP SSRC which builds the core system from scratch from source. You can use this from any unrestricted foreign environment as long as it has the right tools installed. But there's a potential leakage of dependencies from your host system. Say you build something which has an optional dependency which is auto-detected by the build system and it comes in from your foreign system, then you assemble a container which is not the same clean container as you would do from cross-compilation or from void host system. So the solution is make the container from it anyway and then rebuild it once again using those new packages, rebootstrap from binaries and proceed as usual. The outside influence is now gone and you can repeat the process once again just to ensure that there's really nothing. So now we have a complete built environment and that's about 100 packages, but the repo is 11,000 or so and that's just not sufficient. So we need to replace Ubuntu first. Got a minimal container, but this is not good enough to make a host system. It can run inside the Ubuntu system, but it just has command line utilities, no kernel, no graphical environment, nothing. So first is contributing the changes up until now to upstream that happened at one point, and building a desktop, a web browser, and a set of other applications I usually use. No kernel yet, I can just use the Ubuntu kernel for now. But this comes in early, Rust. It's already made its way into a lot of software. The first thing is librsvg2, which is an SVG library used by GTK and other toolkits, pretty much everything. Later on also needed by Firefox, I mean Rust. Rust is self-hosting. The Rust compiler is written in Rust. We don't have any Rust compiled, so what do? Well, fortunately for little Endian, Mozilla provides official binaries for glibc, so this problem is solved for now. We can just use Mozilla Snapshot. With Rust out of the way, most things got built. The other template changes were mostly minor, so I could replace Ubuntu userland. In order to reinstall without having a kernel. I just create a small root in RAM in tmpfs, then mounted the real root into it, erased it from inside of the temp root, and then installed a complete new user ant into this. Then I refreshed the initial RAM disk and bootloader and rebooted, and it worked. The next step is dog fooding. So it's been 3 days since I started porting, and I already have a graphical system. So the next step is kernel. I took Ubuntu kernel config, the x86 64 config from Void, rebased Ubuntu config on the most recent kernel we had, synchronized with using x86 64 kernel from Void as a reference for platform-independent changes. And after a few iterations, during which I had to non-booting systems a couple times, I had it working. The obvious next step is adding more targets, because just one is not enough. This is a Void running on a PowerMac G5 with a big Endian userland and everything else. So the next plans were little Endian with muscle libc instead of glibc, and also big Endian with glibc and muscle libc. I used cross bootstrap for this. It was easier. I could do it directly from my system, and I had no native big Endian built environment so far. There are some differences. Little Endian requires at least Power 8. Well, really, you can get things to run on Power 7 too if you compile for it, but it's not really worth it. Big Endian requires at least PowerPC 970 or G5, and it also requires vectors, Ultivac. Weird choice I made, which is in line with our approach to be legacy-free. I used the modern ELFV2 ABI for big Endian as well as little Endian. Most distros which have existing big Endian support use the 30 years old ABI. I thought there was not really any reason to do this. Besides, muscle libc already requires ELFV2 by default, even on big Endian. glibc was found to be working quite fine also. It didn't work some years ago, it works now. And 32-bit PowerPC. This is a PowerBook G4 with Void running, as well as a web browser in it based on WebKit. After all these years, it still works, which is nice. It only required a small patch in JavaScript core, which did some bad assumptions about Endian. An independent effort to port to 32-bit was started by someone else, and it was merged upstream separately. It's also for glibc and muscle, and it's a generic PowerPC with no Ultivac requirement or anything else. Later, because it was overlapping in many places, we merged this into a single effort, and now I'm kind of maintaining all of it. But first, bootstrapping big Endian. We needed native packages for big Endian, also 32-bit, so we needed a native built environment. The choice of distributions was limited, but there is one. It's called Adelia Linux, which is sort of leading some porting efforts in the Talos community right now. There's first-class big Endian support, so I just used their live media plus a statically linked copy of the XDPS package manager to actually successfully install Void on KVM and bare metal computer. So the current status. On the left picture, there's a Nintendo Wii U, which is a 32-bit PowerPC console running our system. And on the second picture is a Power 8 server, which I acquired during the time I was porting, also running the system. The current status. We have a dedicated 18-core and 128 gig RAM Power 9 build server at Talos 2. This takes care of building all the packages. For big Endian, we use KVM. The nice thing is that you can actually have a big Endian VM in KVM, and it will work with no speed loss. It just works. it is given half the resources of the machine, and it's all running void, of course. The majority of the repo, maybe 2/3 or so, are built for PPC64LE now. At least every major desktop and various applications are supported on all the other targets. I expanded this a lot recently, so at least half of the repo is built for everything now. It's production ready, I would say. I'm running it on the Talos 2 on my Blackbird desktop, which is my daily driver system. Some of these Power8 servers, I have 2 of them, a PowerMac G5, a PowerBook G4, plus others are testing it on different, more rare machines, even the console. Now, live media. Upstream Void already has a sort of a live media creator based on some scripts and an installer. These needed to have PowerPC support added. This was actually not a big deal. All it needed was really adding the bootloader support for legacy devices using open firmware, as well as updating the arguments for ISO creation to create a different kind of ISO more suitable for, say, APM-based systems and so on. The installer supports OpenPOWER environments. If it detects those, it skips bootloader because there's petted boot. It also supports open firmware, either SLOF on IBM machines or Apple on old G5s, G4, and so on. The live media can also boot on all of these machines without problems. There's a small issue recently discovered that some specific version of firmware on iBooks G4 has some bug which leaves some trash in the memory management unit, which prevents grep from running. This was I found out about this in an unrelated discussion about something else. There's a workaround for this, fortunately, so grep can still work on that. The little Endian media work on Power8 or better, the big Endian on the G5s and lots of other things, as well as modern Power8, Power9. Ever since Linux 5.0, you can have a generic kernel made for Power4, which will boot on all the old machines as well as all the new machines. There was some bug before which required you to compile a separate Power8 kernel for modern machines if you wanted to run big Endian. The 32-bit media boot at least on G3, G4 machines, anything with modern open firmware. Other machines can be installed via root file system tarbles. Now some organizational things. We have a staging area for upstream at this URL, and most changes are submitted to Void upstream immediately or to software upstreams if needed. There's different things I come across when porting which need patches created for Power. I tend to submit these as soon as possible. Also, another purpose is spreading awareness and keeping the patch count low. Having lots of patches in the local tree would mean lots of overhead to deal with, and if you have just a few people, it's not desirable, so it's better to just fix everything in upstreams if possible. Also, Void upstream cannot accept new builders right now, which means the current infrastructure, which is separate from the upstream distro, provides all the repos. We also have documentation, live images, FAQ for common issues, root file system tarballs, statically linked builds of XBPS, so you can use it to install from any different distro, no matter what environment, as long as it has a recent enough kernel. There's multiple contributors by now, though most of the work is currently still me, and we have an IRC channel on Freenode. Now, there are some oddities about Void which are different from most distros. One is, as I mentioned, ELFV2 ABI for all 64-bit targets. This is used even for the kernel. There was a bug during GCC 9.1 series when C flag used by the kernel to build on Big Endian was undefining some macro which the Linux kernel relied on. Instead of working this around, I just switched the kernel to ELFV2 and it it works even on ancient bootloaders and everything. I was surprised it does. ELFV2 has some advantages. It has cheaper library calls. It's more sane. It has no function descriptors and that kind of nonsense. We're a legacy-free port, so there's no reason to use 30-year-old ABI. Another difference is that we use kernels with 4K pages. Most distros nowadays use 64K pages. It's great if you have a single-purpose server with lots of RAM in it and running a database or something like this. It's not desirable for a desktop system, I think. You're better off with less fragmentation and better compatibility with different software. For example, BTRFS file system, if you want to use it, it will BTRFS pools created on 4K kernels like x86 and so on will not import on 64K kernels. BTRFS pools created on 64K kernels will not import on 4K. Also, I heard that there are some actual real problems with 64K BTRFS, even beyond just wasting, like being inefficient. So we use 4K, and it works better. Also, 64K is only supported from Power 8 onwards. On older hardware, it will get emulated by the kernel. There's not much harm to it, but it's still not natively supported. 4K is supported in hardware on everything. Now, some Endian and ELFV2 related troubles. This is a Western Wayland compositor running with OpenGL acceleration on a big Endian system. With software Pixman, it works, oddly enough, but the DRM backend is severely broken. So one thing is inverted color issues in some applications, mostly web browsers. WebKit, oddly enough, works great, even after all these years of not many people testing it, no rendering issues whatsoever. Firefox has had issues ever since switching to Google's Skia library. Before it used Cairo and it worked okay. Nowadays Mozilla patched a lot of it and it mostly almost works again. Some CSS transforms still invert the colors, but it mostly works. There's driver issues, no AMD GPU driver on Big Endian, at least not last time it was tested. I'm planning to retest it again soon. There's no Nouveau driver for NVIDIA cards, for modern cards. The micro semi SAS controller present on dual socket Talos 2 boards doesn't work, and possibly other things. There's applications or libraries which sometimes like to assume that ELFV2 is always little endian and ELFV1 is always big endian. This is not correct, but it's easily fixed by switching like from ifdef little endian something else something to if call elf equals 2, then do for ELFV2, otherwise ELFV1. There's also patching needed for different things, for different issues like Valgrind, Rust, OCaml, other software. Now, let's get back to Rust. It's currently most important because there's lots of things using it. It needs custom bootstrap binaries for PPC64 because of ELFV2, and for all of Muscle because they started shipping Muscle for x86-64 just recently, but not for any other targets. So we need custom stuff for these. There are some compiler stability issues on Muscle and PPC32. The latter actually got solved recently. Another contributor in the community found it and submitted patches for it, so we ship the patches now. It's a bit immature and it's hard to debug. It's annoying, but it has wide platform support and self-bootstraps everywhere, which is, on the other hand, pretty nice. It's better than Haskell, for example, in this regard. Now, Go. This is problematic, just like most Google software. Google has been pretty hostile as an upstream for power support in different things, including Chromium. There's a full patch set for Little Endian PPC64 lying around. It's not accepted, they are actively rejecting it. For Big Endian, it only has ELFV1 support, and it requires Power 8 instructions, and they're not planning to go back on that, which means we cannot ship it because it would mean shipping packages which should only work on some computers. There's no support for 32-bit PowerPC, and the shared linking model of theirs makes it a pain to cross-compile between libcs. Like if you try to cross-compile from glibc to muscle, it will just consider it not cross-compiling, and it will generate broken binaries. There's also bootstrap issues. It currently is only provided on glibc, pp64le. There's also GCC Go though, and this actually works on all targets. Muscle doesn't work out of box, but it was patched, so it works now. And it's more or less drop-in. You can just replace the Go binaries with the GCC Go ones. Java, this is currently only on Little Endian. Not because it wouldn't work, it's actually pretty portable, but it's hard to bootstrap. There's no binary sources or few binary sources beyond pp64le. The current plan is to reintroduce the old GCC Java support into 3 as a bootstrap compiler for JDK7, then use that to bootstrap 8, 9, 10, 11, all the way from source. This will also ensure that it's trustable, but it's also lots of computing power. But this doesn't have to be done all that often, so it's probably okay. Haskell is fully self-hosting, and it also requires a very recent version of itself to self-host, to self-compile. And it's also extremely difficult to cross-compile, almost impossible. It involves using QEMU to emulate the target architecture during stage 1, apparently, so nobody figured this out yet. So I have bootstrap binaries available for Little Endian, done using those from another distro. I plan to introduce the rest once I figure it out. I don't think many people have figured it out, so this will be an experience. There's also the stack package manager, which is used to build Haskell programs, which downloads its own binary toolchains, which is kind of odd. There's none for PPC, so I have to force the system GHC. And others, most other languages have multiple implementations or working C implementation or are not self-hosting, so these are usually okay. Some, like for example NIM, are self-hosting but choose to compile to C and provide some pre-generated C to bootstrap from, so that's okay. And Common Lisp is pretty problematic, but can also be solved. Web browser, as mentioned by the other Dan here, there's no JavaScript JIT for Firefox. There's one in Chromium, but there's no pp64 support in Chromium. Firefox works alright. There's some minor color issues because of Skia, but it's alright, it's being patched. There's no Firefox on 32-bit PowerPC. Rust C used to segfault. This was fixed by the recent patches in Rust. But it still segfaults on startup because of some glue code it has. WebKit works pretty much flawlessly. It only required some 15-line patch in JavaScript core to work on Big Endian, and it's okay. Additionally, the code base is pretty nice and organized, unlike Blink, which is kind of interesting. They seem to have a lot of emphasis on keeping the code clean and portable. There's the Chromium patch set, but it's getting rejected, and it's too fast of a target to maintain packages downstream, so I do not. I at least do maintain packages of Qt 5 Web Engine, which is based on Chromium. I don't think any other distros do this right now. Maybe Fedora will do it at some point. Yeah, we have it for now, and it's some 8K lines of code patch. It's fortunately Qt 5 Web Engine iterates fairly slowly, so it just means redoing the patch every few months, but still it's a pain. Games and multimedia. Here's Doom 3 running on PPC64. Here's Elder Scrolls Morrowind running on PPC64 using the open source engines. The open source games usually work, and Raptor got a version of Unreal Engine 4 working. They showed it some time before. The well-known open source games or engines are packaged like Sonatic, OpenMW, and so on. We also have a variety of console emulators for, say, PlayStation 1 and the Nintendo systems and so on. all the common multimedia codecs and players and so on are packaged, and they have worse performance than on x86 because of fewer optimizations, but they work all right. So overall, the state of the ecosystem is pretty good, and I'd say Power is a viable desktop platform. It just needs some more effort put into it and have more hardware and so on. I'd say over 90% of the repo, it's more like 95 or 97% for little Endian stuff, can compile for either target, even for 32-bit PowerPC, which has the most issues, it's like 92%. For detailed statistics, there's some statistics here also. And thanks for listening. Now, if you have any questions, I can answer them.
Questions for Daniel? I guess I'll ask the first one, give him a chance to warm up. Why, I mean, I get why you started with the first image, right? Your own Void Linux for PPC64LE. What was the, was it really just for the sake of proving you could do it across all the other pieces? The big Endian, the 64-bit, 32-bit? You know, what motivated you from the first distro to as many as you could, I guess, was the question.
Well, the goal was really to enable people with older computers to run the distro also. There's currently a shortage. Most of the other distros went obsolete. Like most distros removed those targets. Also, it means that if they can have it working on, say, their PowerMax G5 or PowerBooks and other kind of machines, they might be interested in, say, buying a Talos 2 at some point, maybe, continuing using the platform as their choice of platform even in the future.
Okay. I got it. All right. Other questions? You seem like a guy who's really busy. I mean, really busy. That was impressive. Any other questions? Leave it to Anton to ask a question here. It'll be a good one too, I'm sure.
Thank you, Daniel. This is great work. I was just going to ask, what can we do about the specific situation you were alluding to as far as Google accepting some patches that enable some of those pieces? Is there anything specific they need from us, or what are we blocked on?
I believe Timothy from Raptor has already reached out to IBM and it actually helped to a degree because some of these patches got accepted, but currently the sandbox patches, which are the most important, because without a sandbox it will just not run, and running without a sandbox is kind of a bad idea on modern web with all the modern web technologies. The sandbox team is still rejecting it as far as I know, and it's been up for review for many months and still remains as it is. But the other patches, some of them got accepted, and it's slightly smaller now, the patch that I mean.
Okay. Any more questions? If not, let's give him a big round of applause and thank him for both his presentation and his work.